Have you ever wondered how millions of people can all try to buy concert tickets at the exact same moment without the whole internet just collapsing? Well, there's an unsung hero working behind the scenes, this invisible piece of tech that keeps our digital world from completely grinding to a halt. So let's dive in and see what makes it all feel so effortless. We have all been there. A huge new product is launching. Tickets go on sale and bam, the website you're on just dies. But why? Why does it seem to happen right when you need it the most? Well, it's pretty much a digital traffic jam. Imagine every single user request being slammed into just one server. It gets totally overwhelmed. It's like the busiest shopping day of the year, but there's only one cashier open. It's pure chaos. And the results? That error message we all hate to see. 503 service unavailable. But what if you could magically open up a dozen more checkout lanes? And what if you had a super smart manager who could direct every single shopper to the shortest line instantly? Well, in the digital world, that's exactly what you can do. It's time to meet the hero of our story. So what is a load balancer? You can think of it as the internet's master traffic controller. Its job is actually pretty simple in theory, but it's absolutely critical in practice. It takes all the incoming requests and cleverly spreads them out across a whole team or a pool of servers. This makes sure no single server ever gets buried under all that work. So you can see how the entire architecture gets a major upgrade. A user sends a request, but instead of hitting that one overworked server, it first arrives at the load balancer. The load balancer then acts like this brilliant dispatcher, taking a quick look at the request and sending it to which other server is best equipped to handle it at that very second. Now, this isn't just a random guesswork. A load balancer is a really intelligent system, and it's making these calculated decisions in just milliseconds. Let's peel back the layers and see how it actually thinks. It all really boils down to two main jobs that work together perfectly. First, it's always, and I mean always, monitoring the health of its server team. And second, it uses a set of smart strategies or algorithms to route all that traffic in the most efficient way possible. So the first job is basically playing doctor. The load balancer is constantly sending out these tiny little messages or health checks to every server. It's like it's asking, hey, you doing okay over there? Can you handle some more work? If a server doesn't answer back correctly or if it seems sick, boom, it's immediately and automatically taken out of the active rotation. And this right here is the magic of what we call fault tolerance. By spotting a problem and instantly rerouting traffic away from a failing server, the load balancer makes sure that you, the user, never even notice something went wrong. The service just keeps on running, requests keep flowing, and the system basically heals itself without any interruption. Okay, so the load balancer knows which servers are healthy, but how does it decide which healthy server gets the very next request? Well, it doesn't just guess. It uses a set of rules or algorithms to make these smart routing decisions. Let's take a look at a few of the most popular ones. The simplest method is called round robin. Seriously, just think about dealing a deck of cards. Player 1 gets a card, then player 2, then 3, and you just keep going around the circle. The load balancer does the same thing with requests. Server 1 gets one, then server 2, then server 3, and right back to the start. It's simple, it's fair, but it does assume that all the servers are equally powerful and all the requests are pretty much the same. Now, a much smarter way to do things is the least connections method. This time, before sending a new request, the load balancer takes a quick peek and checks which server is the least busy, the one with the fewest active connections, and sends the new request there. It's exactly what you do at the grocery store, right? You look for the checkout with the shortest line. It's just way more efficient because it knows some tasks take longer than others. Then we have something called IP hash. This one is all about creating a consistent experience for you. It uses your unique IP address to make sure that all of your requests for your entire session always go to the very same server. Now, why is that so important? Well, think about an online shopping cart. If every click sent you to a different server, that new server would have no idea what you just added to your cart. IP hash creates this stickiness that keeps your session in one place. So let's pull this all together in a quick cheat sheet. You can see round robin is great when your servers are all pretty similar. Least connections is the winner when requests might take different amounts of time to process. IP hash is your go-to when you need that session stickiness. And you'll also see another one here, weighted round robin, which is just a fancy version that lets you send more traffic to your beefier servers. The big takeaway here is that there's no single best algorithm. It all depends on what your application needs to do. All right, so now we get how they think. Let's talk about the where. Where are these digital giants actually working? And what different forms do they take? Because, not all load balancers are created equal. Okay, one of the key differences is whether they operate at what we call layer 4 or layer 7. Now, this gets a little technical, but the analogy makes it super simple. A layer 4 load balancer is like a mail carrier who only looks at the address on the outside of the envelope. It's really, really fast because it only cares about network info. A layer 7 load balancer, on the other hand, is smarter. It can actually open the envelope and read the letter inside. It understands the request itself, like the specific URL you're trying to visit. This lets it make much more intelligent decisions. The trade-off is simple. Layer 4 gives you speed, while layer 7 gives you intelligence. So where do you find these things? Honestly, they are absolutely everywhere. They're the backbone of every high-traffic website you visit, from news sites to social media. They manage all the data flowing to the APIs that power your favorite apps, and, of course, massive e-commerce and streaming sites couldn't survive for a minute without them. In fact, they're absolutely essential for the way we build modern software, especially with something called microservices. That's where you break a huge application down into lots of tiny, independent services. The load balancer acts as that central traffic director, making sure a request to see a user profile goes to the user service, while a request to make a payment goes to the payment service. It's really the glue that holds these complex systems together. All right, we've covered a lot of ground. We've seen how they think and where they're used. So let's just zoom out for a second and recap the incredible benefits they bring to the table. And trust me, it's about so much more than just preventing crashes. It really comes down to these 4 pillars. High availability, which just means your service is always on. Scalability, which is the freedom to grow and handle more traffic by just adding more servers. Fault tolerance, that built-in safety net against failure. And finally, improved performance, which means a fast, smooth experience for every single user. But if there is one thing you take away from all this, let it be this. By spreading out the work, you completely get rid of the single point of failure. If one server goes down, it doesn't matter. It doesn't take your whole app down with it. The load balancer just reroutes traffic around the problem, and you, the user, are happily clicking away with no idea anything even happened. And this is the number that everyone is chasing: high availability. In the tech world, we talk about the nines of uptime. 99.99%, or 4 nines, means a service is down for less than 1 hour over an entire year. Think about that. And load balancers are a fundamental piece of the puzzle to achieve that incredible level of reliability. So yeah, they're the true unsung heroes of our digital lives, working 24/7 behind the scenes to make this incredibly complex, interconnected world feel simple, fast, and effortless. And it kind of makes you wonder, doesn't it? What other invisible giants are out there quietly making modern life possible?